Cool. Welcome, everyone. Today is August 17th, and this is another instance of SIG Apps bi-weekly meetings. My name is Maciej, and I'll be your host. Looking through the attendees, I'm not seeing Janet, but I remember she should be joining us, so I'm guessing she'll be here in any minute. Anyway, quick announcements. A 137 Kubernetes release is planned on August 26th, so that's roughly 9 days from today. If you got a ping from the SIG release or any of the release teams, please make sure to respond promptly and help unblock them, whether that's a flake, a problem with your feature, or any of the PRs that are require your input, review, or whatever they request. So please make sure that and respond promptly. Another information, we are going to hold a SIG Apps session during KubeCon NA in Salt Lake City on November 10th at 5:30 p.m. If you have any particular topics that would like to see being discussed, or you want to just chat with us, feel free to let us know if there are any particular topics or anything that you'd be interested in covering. So with all that out of the way, we can move quickly to the main discussion topics. And Nabarun, your CNCF Kubernetes workload conformance topic is the first one on the agenda. Do you want to share your screen, or should I just open the doc?
I'll share my screen. So basically, since the dock is, sorry, my video is off, some internet issues. So I'm just preserving bandwidth.
Yeah, that makes
So
sense.
I'm going to share my screen.
I think I'll
Can
need to
you,
make, yeah,
yeah,
I'll make you co-host. You should be now able to share your screen.
yes, all right. Um, so this is the big document that I shared over the mailing list and as well as what is there in the meeting notes. But in order to save time, what we can do is people can keep looking at it asynchronously while I present a short slide deck, which should like capture the essence of what needs to be the first read from this doc. So first of all, like thanks for giving the agenda slot to talk about this. Essentially, like two things that we really want out of this next 15 minutes is that we get SIG Apps like co-sponsoring us a working group to run the specifications of the program. And we want your feedback on the initial requirement set of specs. Even before we get rolling into like working group, we would appreciate feedback. Um, so let's see like why are we here? We want to establish like why this problem is important and why we want to solve it. Um, Certified Kubernetes did its job, right? It created a standard for the layer of infrastructure. It standardized it and stopped the fragmentation that everyone feared. So API behavior is not predictable. So the control plane behaves exactly the same if it is conformant. Um, but nothing equivalent actually exists above that layer. Um, what this means is two groups of people, one group which create those workloads and another group which consume the workloads, the end users or the platform admins, both have to pay for it. How? The platform admins need to re-audit every workload themselves, whether they follow the best practices or not. And because there are no shared conformant structures for them to verify. How do the workload maintainers pay for it? They have to answer the same questions to every customer of theirs and every user of their software. And this is all done separately in private threads, or if they're an open source project, they do it as part of their documentation, but they still need to keep answering. This is where it costs everyone in the ecosystem. For example, workloads may break in the same handful set of ways for different sets of people. a deprecated API call might be done by the workload. The API version might be removed in the next Kubernetes minor release. What would happen after that point? The workload will break. So all these things need to be taken care of when uh, somebody creates a workload. There are other problems, like a multi-replica workload with no PDBs um, will be taken down by routine node train. Missing requests and limits, they become kills later under load. Uh, Containers which might still be using root and problems like that, so on and so forth. There are a lot of war stories that we have seen as part of our end users when workloads don't follow the structure that we ask them to follow. Now, you may also say that many good projects already do all of this. I agree. But they have no way to demonstrate that they satisfy all the practices that are good as a Kubernetes citizen. And platform admins also don't have a way to tell them apart from the projects that don't follow the good practices. So this is not really any kind of negligent story, but it's a story where we want to make sure like everyone has the capability to certify like how they behave, or if they behave well according to the Kubernetes standards. Now, what do we propose? We're proposing a hydrophone based tooling similar to the Kubernetes conformance program, where we check how the workload behaves inside the cluster using the conformance image. We are not just checking declared intent. What we are checking is how it actually behaves inside a cluster. The workload or the unit of components that the customers or the workload maintainers have specified that they want to check. In this set, the workload is deployed in its full intended configuration on a certified cluster. So the substrate always is certified. That we have proved with the Kubernetes conformance program. We exercise a few things. The conformance program can essentially do a disruption on the cluster and see like how the workload behaves under a disrupted scenario. Now, you might wonder like who pays for the cluster time? Who pays for running this thing? So the submitter need to run the suite in their own environment, exactly like certified Kubernetes. We don't host any infrastructure for this certification. What they need to submit with us is like, what was their workload? How did they test it? Basically their environment configuration, and then we verify on the certification side. Then the obvious question comes like, who counts as these things we certified? Like what do we count? So certification basically covers the whole installed unit. Every component that you deploy to deliver your workload is assessed together. However, it is packaged, so we're not determinant on packaging. If it's Helm, Carvel, or however way the workload is installed in the cluster, we look at the live intent. Now, we can discuss, and this is also an open question, like whether we put from the we put out from the conference program things like CSI drivers, CNI plugins, or things like core DNS, which count as like core infrastructural unit of a Kubernetes cluster, and they require for other workloads to run. We can obviously discuss on the scope later when we discuss all of this in the working group. Now, another thing is like one baseline probably cannot fit everything equally, which is when like a concept of profiles can come in. Profiles are basically triggered by what the workload structurally is. The intention is it should never be chosen by its maintainer, basically the workload's maintainer. What we want is that core applies to everything with no exceptions. But where a profile relaxes something, it basically swaps the exemption for a narrower requirement covering the same risks. For example, things like a node agent does not get a pass on host access. So it has to name the containers and declare the capabilities on things that it requires host access because it's a node agent. And so forth, like stateful data, platform extension, or batch or AML workloads. Like there are multiple profiles of workloads. So you might wonder, like, what is actually in the set of checks that we want to do. Currently, we identified like 22 set of checks, 18 must and 4 should, which are written against like Kubernetes 1.36. But I do want to strongly note here is that this is just the starting point. This is just some suggestions you will see in the uh, proposal document that is linked on the meeting notes. But these are meant to change. These are meant to move around. This is just a suggestion to begin with. And I would like to invite disagreement on this slide. This is very fair to have disagreement on this part, like what do we actually check? Now, how is this set organized? There are ways that you can cluster them into domains. For example, like access control, there are 3 must checks, or API stability, or checking deprecated APIs, there are 2 must requirements. I don't want to read the slide, but you can look at the doc and essentially infer like what is there and what is not there. You might also wonder, like, why is there no domain for XYZ kind of things? That is, again, exactly what we want to discuss in the working group. We want to finalize this set of specs that we consider stable and then ship it for the conformance program to actually check for each workload. There is a clear direction that we want to go through while we design this program, is that every check that we push towards the stable spec, it should be machine checkable. It should be verifiable by a program. We really don't want to ask the customers to provide us like textual evidence and somehow tell us like how do we do things, or the workload maintainer needs to run this and get through like everything in a machine readable and machine checkable way. That is the proposal essentially. Let me show the demo. This is recorded. Still, it is not showing up in the presentation. Let me see if it works from here, or I have the Google Drive open. Bad pixelation. Okay. Can people see this?
Yes, we got your screen.
Yeah, if you can make it full screen, then oh yeah.
Is it better now?
Yeah, it'll be much more readable for the recording.
Okay, awesome. Thank you. I'll share the recording. I'll share the recording as well in the document so that you all can take a look later. But this is very similar to how the Kubernetes conformance works today. We have a demo cluster running, and what we will do now is basically deploy bookinfo, which is like a very standard application to test like network configurations. I think it's built by the Istio folks. What you can see is like what is deployed on the certified Kubernetes cluster. So this is a vSphere Kubernetes cluster, which is also a certified Kata certified cluster. Doing some tweakings. So the first part of the demo is like how bookinfo doesn't conform to be a good citizen. You will see a lot of failures. You can just go ahead. This is showing all the workload. So let me pause for a little bit. So this is how you run the conformance program. You have hydrophone. We'll ship one conformance image that people can run, and then they can give like how do you select your workload? What is the common surface? And then you specify the namespace as well, where your workload might spread to. This goes through. I think you might get a pixelated view again. Really sorry for that. But this is basically Gingo based behavior driven tests running. And and at the end of it, you get the result. So this is for a scenario where things are not working. Now, let's see for a scenario where it is working. It is the same app. We just made some modifications to make sure like we go through the standard set of checks. So I'm just waiting for the buffering to finish. But if you see like here, some of the tests are skipped and some of the tests are passed. So it depends on, for example, like if you're not defining any CRDs, then we don't do the API stability checks. So that's fair because if you don't ship CRDs, there is no CRD to check for. So that is how the output will be. The idea is that you will take the JUnit XML and the E2E log along with the output of how your cluster looks, what CNI you are running, what CSI you are running, and what Kubernetes version you are on, and then you dump everything as a PR to the conformance repo. And then CNCF will do the checks and then give you the certification. We can see like how the boundaries are split. Before that, like I just want to mention like some of the things that we really don't want to check. We don't test the cluster because that is already tested by Kubernetes conformance. We don't check AI readiness because AI readiness of the cluster is already checked by the AI conformance program. We don't want to check the business logic of the program or business logic of the workload because it's not in scope. We only want to see how they behave with Kubernetes. We don't want to dictate like how they should do their business logic. Audits and scanning, formal assessment is part of like other security domains. We don't want to mandate any package format. Bring your package format. All we want at the end of the day is to get like how can we select your workload using label selectors and a namespace. We also don't want to get into like benchmarks like latency and performance metrics. That is also something which is in the business logic domain. Now, if you see the three programs neatly verify three different layers or three different areas of the cluster itself, the capabilities of the cluster, and the workload running on top of the cluster. Now, the governance. We have two entities here. What we want the Kubernetes community to do is define the standard, the requirements, the musts, the shoulds, how the verification is done, the verification suite, which is released per Kubernetes version, which profiles will be tested, and basically be an authority of the tooling. And then CNCF will administer the program. They will take the spec that the working group and eventually a sub-project under SIG architecture maintains. And CNCF will basically use that to verify the submissions. They will grant or revoke status. They will handle the trademarks for conformance or any sort of vendor participation terms, or they will handle all disputes related to the certification itself. The lifecycle of the certification, the workload maintainers execute the suit, they submit a PR to a CNCF repo. The evidence is then validated, and then the certification is provided. Kubernetes patches always inherit the status because in Kubernetes patches, we really don't do any sort of feature changes. So the spec is expected to not change in a patch. Even for minors, if there might be cases when Kubernetes doesn't ship anything, which can ideally be going into the spec. So if the spec remains same, the validation for the same workload should continue or should extend to the newer Kubernetes minor as well. And then like expiration of certification. and all of those things. This also might invite questions like how much work it is for the sub-project, but that is all things that we need to figure it out later. But the Kubernetes working group and eventually the sub-project will only deal with like setting up the spec and the tooling. Now, why we are presenting here? We want SIG Apps to co-sponsor this working group. We will also present in SIG Architecture to ask SIG Architecture to sponsor this as well. And we're open to like cross-SIG review from all SIGs in Kubernetes, but maybe to start with like API machinery, node, storage, networking, scheduling. Then we have working group batch, working group node lifecycle, who are also working on some pod lifecycle areas. We really want the working group to eventually end up as a durable sub-project and a long-running sub-project under SIG architecture once we reach like the first GA spec. And right now, what we are asking is also to give like feedback on the initial set of requirements. What is like reviews on what we have thought about till now, what is missing, what can be dropped, and all of those things. Having said that, these are long-term open questions as well, not necessarily to be answered now. I want to open up the floor for questions, comments, or concerns about this.
Does anyone have any questions for Nabarun? Yeah, go ahead, Janet.
Yeah, so I was wondering who will be the vendors who file for certification?
Do you mean like would that be will this be open for any vendors out there, or is there a criteria for vendors? Is that the question?
I mean, is it the platform vendors or is it the app vendors?
It will be the app vendors who apply for certification.
I see. Because from my understanding, if it's a CNCF program, the vendors need to be CNCF members as well when they file for certification.
Mm-hmm. I think GFA, Chris, you're also there. You can also take up the CNCF related questions.
That is correct. If on the administration side, we shape it the same way as both the platform and AI conformance, any certified app in this case would need to come from a vendor who is already a member, or they have to pay a fee. That's how both of those conformance programs work.
And are we also saying that each app is certified separately? And if a vendor has 4 apps, and they end up with 4 certifications, number one, or
yes, the app is for a app. Sorry, the certification is for an app and not for the vendor themselves. So a vendor can have like 4 different orthogonal functionalities and 4 different apps basically. So they have to certify each of them.
okay, and like how will they kind of like showcase the certifications that they get from us? We are telling them, look, you can use this logo or whatever that we come up with only on that specific workload that pass the conformance workload conformance.
Yeah, that's how that
Yes.
would work. Similar to AI conformance with platforms, it would be an entry on the landscape, and that entry would then have a little tag that essentially says, yes, this is Kubernetes workload conformant, whatever we name it, right?
Like one basic question is, anybody who's developing the apps, this is their bread and butter, right? Like they want to support as many Kubernetes versions as possible at the same time. They want it to work as well as possible. So they make sure that they test against multiple vendors. Each Kubernetes vendor has their own quirks, even if it is conformant or not, right? So like what are we giving them over and above that, that's going to help them with their customers, so to say? Like, what is the value? Like, why should they spend time doing this, so to say?
So the time saved here is basically when they have that sticker, when they have that logo on their app, their customers, like, for example, if they have 100 customers and those 100 customers don't all need to do the due diligence of whether that workload behaves like a good citizen or not. They can rely on this certification, similar to how the Kubernetes certification also works.
Mm-hmm. Okay, then the opposite side, right? What is the incentive for the community members to be part of this working group and define these standards? Like, and how will we sustain it over a period of time? There might be a lot of enthusiasm right at the get-go, but then, as like conformance program right now is short of people, right? Like in general. So how would we do this in like, how are you thinking about it so that it's going to be sustainable for the longer future?
My vision here is that it will reduce a lot of noise that we are getting into other SIGs. Like, why is XYZ not behaving in SIG, like in a foobar way? I feel like we will cut down a lot of those questions and hence will reduce some effort as well.
I don't catch that. Are you wearing a Kubernetes community hat, or are you wearing a...
I'm wearing a Kubernetes community hat here.
Okay. But then, like, where is the incentive coming from for a vendor to allow their people to come and do this work here that needs to be done to keep it running for the long period of time? You see what I'm saying?
Yeah, that's on the vendor side. That's a good question.
We all have day jobs.
Yeah, I know.
It requires work, ongoing work, constant work, especially when you bootstrap. Yes, there is a lot of enthusiasm and interest, and you plow through those things, but over a period of time, it's going to become harder and harder. Think 5 years from now or 10 years from now.
Yeah, we need to build like some self-sustaining mechanism.
Yeah.
With which, like, whenever we deliver like a GA feature, we somehow add this like requirement, which is in a machine verifiable way. Just like how we are promoting conformance tests right now. Things go from when features grow, they're expected to have E2E tests. Then once they are stable for some time, and when the feature goes GA, we determine whether it is promotable to conformance or not, subject to other requirements as well. Maybe
right. Here the workloads may or may not support that feature, right? Like you were talking about the CRDs.
Yeah, so then the workloads won't be set conformant, right? So if something that we say in the Kubernetes community,
we can't mandate that they use CRDs, right, Navaran?
If they don't use CRDs, the CRD checks don't get triggered.
Exactly. So if they don't use the newer features that's coming out of Kubernetes, then it doesn't.
Yeah. So that's why we visioned the idea of a profile, because evidently, like, not all workloads are of the same shape and size, and they don't leverage all features.
Okay, so the learning from the existing conformance program is we tried to do profiles. It's just harder. It makes it, if you have 5 profiles, it's 5 times harder than doing one, right? So that is part of the feedback to your this thing, that, like, do not just focus on the core one right now.
That's a good one.
Yeah.
That's a good one. Yeah.
Yeah.
I think this deserves like good discussion.
Yeah.
Later on as well.
I agree. Totally. Like, this is like, just giving some dump of thoughts in a public forum. So you have it for the record, and, you can think about it while you are, and folks here can think about it too, right? The other one, I'll ask one last one, and then I'll stop. So there are specialized workloads for AI, right? Like Janet, is here, and she'll be thinking about how does this help with or hurt the other things that we are doing, right? And Neer was also talking to me about some stuff around how do we deal with something specialized, right? Those are not general purpose apps, but special apps that do special things, right? So how would that work with this program? That is something that you need to think about in the future as well. I'll stop right now and let other people ask questions.
Janet, before you go, Mike had a comment regarding wouldn't behavior changes based on cross-app resource conflicts. I don't know if you want to add to that, Mike, or it's just fine to follow up at a later time.
James was hitting the direction I was going. There's just too much going on in the background, right? How will we know as a user in a multi-tenant environment that I can run this conformance app? What's the benefit if I'm running non-conformance apps at the same time, or two conformance apps that weren't tested in one profile? I'm just trying to figure this out.
Okay, I guess.
The noisy neighbor problem is something that I was thinking about when we were trying to define the base set of specs. I really could not get a direct answer, like how do we define those? But I'm really open to discuss this. Feel free to drop a comment over in the doc.
Go ahead, Janet.
So what's the release cadence of the conformance? Because every app has their own release cadence.
Since this is related to the Kubernetes APIs themselves or Kubernetes functionality, the idea is that at maximum, there would be a release cadence for each Kubernetes miner. But if there are no changes, which can be pushed to be a workload conformance level check, there will be no release. The spec will continue for the next Kubernetes miner. We can just say that it's a no difference between the previous, and the workload certification for, let's say, Kubernetes 1.37 will be valid for 1.38 as well, since the spec is same. And the notion continues.
That was basically one of the comments that I had early on, because on one hand, we know that we're not pushing very hard on adding new functionalities between kube releases into the stable workload APIs, at least from the app running perspective or platform engineering perspective. So I was pushing towards how can we simplify the conformance rules. If we know that between, I don't know, the next two releases, there will be add-ons, there will be features, but the features will be more like nice to haves, but not something that is fundamentally required for running a particular workload. If something like that happens, yes, that's the addition, that's the change to the conformance that Nabarun mentioned. I think that should simplify the overall rollout and the certification process for some of the vendors, and in some periods of time, basically.
I had one more question. So one of the thing in the current conformance program is we are giving the guarantee that somebody, wanting to try something, check for conformance, will be able to run the test by themselves. The vendors are submitting, evidence for sure, but like somebody else will have a run book that they can go look at and run the same test themselves to verify the conformance status. Are we thinking about something like that here, Nabarun?
Yes, Siddhim. So when we roll out the documentation for the conformance image, the idea is that it can be run by anyone. So the vendors first of all, like from the left side of things, vendors know how to run their apps, so they will obviously like put the certification out. And then like any platform admin or an end user who is going to consume the workload, when they install the workload and they know the surface area of what they have installed in their cluster, they can run the same conformance image against their cluster and try to verify the results. So because the conformance image is open, the spec is open, the workload, like we are not party to that program. They have their own commercial understanding or whatever, but they would have access to the workload so they can verify whether the workload is conformant.
But do we like mandate a requirement from the CNCF program side that there has to be a page that documents exactly how this needs to be configured so the conformance will pass, or at least document here is how we have configured our app, so and then we tested the conformance.
So as part of the conformance submission, we will capture the workloads that we have tested, and then we will put it as part of the transaction log.
So does that mean that we'll have a list of all the Kubernetes resources in there?
Depends on how much noise do we want in the repo.
No, I mean in the log will be captured. Here is a set of all the Kubernetes
set of resources for sure. Yes.
Yeah.
Name, namespaces, everything. I want to go one step ahead and log the resource exactly as well. But I'm open to discussion on this because what if it's like 1,000 resources? We don't know how people can crack this out. But yeah, the idea is that in order to have a verifiable record, we need to record the shape that it was verified.
Right, because when somebody is actually trying to run it, and the list doesn't match, then you know that the conformance missed out on something or the other, right?
Yeah.
Okay.
Okay, we spent significant portion of our time on this particular topic. If folks have any particular questions, I would say you can either respond to the email thread that Nabarun started last week. You can comment on the doc that is attached in our agenda, or you can directly ping Nabarun, and he will be more than happy to answer all your questions. I'm guessing we will be. Yeah, go ahead.
Would it be good if people can ask questions in SIG Apps for now?
It's totally reasonable for people to ask questions in the main SIG Apps Slack channel. We will be pulling Nabarun to answer those questions, or he will be monitoring that channel as well and answering those.
Good.
So yes, definitely it's that, and I'm guessing we will be slowly discussing the next steps for the working group with SIG architecture and the remaining SIGs, and people should hear more about how we're rolling forward. We will definitely announce the next steps as we are going.
Thanks,
Thank you
everyone,
very
for
much,
the time.
everyone. Over to the next topic. Mike, I saw you like a minute ago. Okay, I see you. You're here. Do you want to share your screen, Mike?
Yeah, I think I need.
Okay, let me make you a co-host quickly.
Thank you.
Cool. You should be able to share your screen.
All right, appreciate it. I will keep this really brief. In the interest of time. Hello, my name is Mike G. I basically wanted to bring up a potential KEP that I have not navigated this process before, so partially I'm doing this to get like early feedback and also some guidance on where the SIGs want to go with this. So to summarize, I'm going to keep it to just a few minutes really, and then we can move everything to discussions in the doc. But basically, my company, we run large heterogeneous clusters. We have a lot of different node types, sizes, workloads. And a typical problem that we have around daemon sets is that they're difficult to size appropriately for the node that they're running on. Changing the size is potentially impactful because it can result in eviction. They if we want protection under node pressure, we have to use requests for resources in order to gain that. Otherwise, they're the first things to get evicted, and typically they're important things that we don't want to do that with. Um, so because of all these things, I wanted to try to approach it from the Kubernetes side, natively rather than leverage. There's a handful of like sort of outside solutions that are based on operators and custom schedulers and things that try to solve this problem. Um, but I wanted to see like, hey, what would it look like to just put this natively into Kubernetes? And a couple of different solutions are laid out here that you can look through in another time. But one idea, and the reason I was bringing it to SIG Apps is there's this idea of maybe like a higher level object on top of a daemon set that would allow basically different sized daemon sets to come out of that parent object, and that would allow you to have maybe different scales of daemon set instances depending on what your workloads look like. And there is an existing GitHub issue where that's been discussed a little bit. And uh, message, I see you. I think you reopened this issue, which is great. So this could also be a good thing to come back and discuss, and that's linked in the doc. Another solution which I am a little partial to and have been kind of running down is, what would it look like to actually solve this at the node level? Since typically daemon sets and workloads like this, they're typically like infrastructure things. They're logging, they're proxies, things like that. And oftentimes the administrators of the cluster are running them, and we're just using daemon sets because they're convenient. They're easier to deploy these workloads than to build them into the nodes themselves as system daemons. So I thought it'd be nice to be able to leverage the niceties of the scheduler and all of the pod infrastructure that we have, but treat them a little specially, right? So one proposal that I have kind of drafted out here is maybe following the cube reserved or system reserved concepts. Could we support something more generic like a named reserved slice on the node level, and then allow the kubelet to place nodes or place pods in that named slice, and that would sort of takes the resource management outside of the scheduler, and it puts it on the administrator of the cluster to do that at the node level. So that's detailed out here. And there's ways to do it today as well. You can do you can manually define daemon sets that match your node profiles. You can do vertical pod autoscaler in some cases, but none of these quite felt right. They're just not really complete solutions. They solve pieces of it. So that's the background. If there's any like quick questions, we could talk about it now, but I don't want to take too much time because I know there's other stuff on the agenda. So any quick questions before we move on?
Before anyone answers the question, I can definitely comment on the higher level daemon set solution, the option A from your document.
Mhm.
We have a prior example of something similar happening, maybe not necessarily in the core queue, but is being handled as part of the broader SIG Apps umbrella, which is the job set, which basically is doing just that. It allows you to define a set of jobs that the job set controller is then handling for you. So I would envision, and that could be easily roll out already as your own separate project, and then we can discuss eventually bringing this back in under the auspices of Kubernetes 6 under the SIG apps, where we would have that kind of controller, and that could help you at least slowly start building and putting together some kind of like proof of concept. I think I've mentioned somewhere either in the thread or in the document that there is a node lifecycle group that is touching some of the similar areas around evictions that maybe not necessarily tightly coupled with the problem that you're having, but they are somewhat related in some cases at least. Definitely the option B is a topic for the SIG node. They will have to be the one to respond to what are the possibilities for having some kind of like generic mechanism for reserve capacity. And I believe I already left you a comment that rather than targeting a specific workload type, I would probably try to come up with something that will be more generic so that people can use it towards daemon sets or different sets of resources that they find necessary for running their particular workload. So I think that will be the two directions that I have right away. I'm not seeing any hands up. So if
And
people have any, yeah,
I
go
did
ahead.
rewrite the drafts in this doc. I did rewrite based on your feedback on making it
Okay,
generic. So thank
cool.
you for that.
I see Philip and Janet. I think Janet, you were first. Go ahead.
So there is a requirement for protection. Can you use priority for that?
You can. The issue that we've run into is by using priority classes, then you have to then accept the preemption trade-off. So, you can use system node critical, but then you're going to evict workloads, and that's not always an acceptable trade-off depending on, what you're running. Um, so that does work, but it has its own problems.
I believe also the heterogeneity of the workloads that you mentioned in part of the document, where you would want to be able to size the application based on the availability of resources on a particular node, was also a challenge. And because I was looking at the priority classes and how that would fit, that's where the higher level daemon set would be more appropriate, because then you can have different sizes, although there is still the topic of dynamically matching the sizes, which is another can of worms. Philip, go ahead.
Yeah, I just want to mention that we are looking at like a couple of issues or solutions for daemon set, and especially with regards to like the node disruption in the node lifecycle working group. So I think like we have an overlap here, so we could discuss it there as well.
Awesome. Thank you. I'm guessing similar engagement model. Bring it to the SIG meeting and add an agenda item for that.
Yes, ping Philip directly, and he will
Okay.
be able to point you to the necessary resources for the node lifecycle. Alternatively, in the same repo where you find information about SIG apps, you should be able to find information about working group, because that's not a SIG, that's a working group. So that will be WG, and then it will be node lifecycle is
Gotcha.
the working group.
Excellent. Thank you.
Cool. Awesome. Thank you very much.
Appreciate the time. Thanks.
The last on the agenda, and we have like 8 minutes, is Pradeep. I think I saw Pradeep. Yeah, I see Pradeep. Pradeep, you
Yes.
wanted to talk about the DevOps bench?
I was actually going to pass it to Simran, who's on the call as well. She's going to give a quick and then yeah, we'll proceed together.
Okay.
Yeah, I can give a quick intro here. Hello, everyone. I'm Simran. We introduced the DevOps project before, but a quick introduction again, since we have a lot more people now. We started this initiative to create a standardized open source benchmark for evaluating agents on real world DevOps and cluster operation scenarios. And instead of evaluating on general coding stuff and static checks, this bench is targeted to evaluate real world live stateful Kubernetes clusters solving real operational issues. So mostly I want to give a quick update on the progress we've made so far, and highlight the roadmap of what we have plans and how everyone can participate in different contribution tasks that are set up. So I don't think I can present the
You
roadmap.
should be able. I made you co-host while you were speaking.
Oh, okay.
If you can't present, let me know. I can share the screen and show either the. Oh, cool. We're seeing your screen. Awesome.
Okay. So a quick introduction to the roadmap here. We've highlighted different things that are in progress. So we've set up a few pieces of the core harness and the orchestration loop, which is gonna support different agent harnesses and have different model integrations as well. So currently we have support for anti-gravity, OpenClaw, and we are able to run the harness against different models, including Gemini and Anthropic models. We also currently support Kind clusters, B clusters, and GCP provider, but we have plans to expand this to different AWS, Azure, and different providers. And our task library has a bunch of scenarios right now which cover different aspects of Kubernetes operations. But our plan is to scale this to cover much more in-depth scenarios and have more complex tasks set up with different kinds of fault injections to cover different scenarios that the agents can encounter. In the future, we also want to expand this to DevOps Arena, which would cover agent-to-agent competition and compare the performance, how they perform as compared to the same task, and how they perform under different chaos scenarios as well. So there's a huge list of tasks we have completed. There's also contribution guidelines for different tracks where people can participate in. There's task authorship, harness, and models, and there's a lot to expand on the verification and metrics as well. So this is what I wanted to give a quick update on. Pradeep, if you want to add anything, feel free.
Yeah, thanks a lot, Simran. I think the main thing that we wanted to sort of highlight was like since the last time we presented, we've gotten a lot of feedback on some of the core aspects that we are evaluating when it comes to agentic performance, and we're also publishing overall scoring methodology guidelines in the PR is actually going up on the repo right now. But I think the main thing that we wanted to highlight from like what it is that we are aiming to do is we've expanded the methodology by which we score agent performance to from merely just like focusing on like whether an outcome is reached to focus a bit more on safety and efficiency of the agent. Specifically, we're looking at does the agent actually take any unnecessary or like dangerous actions like breaking out of its current namespace into the prod namespace, or like is it trying to like replace workloads without like explicit permissions and like those sort of safety criteria, and like trying to our hope is to kind of especially as agents are used more and more in like operational scenarios, like find ways to detect or help operators of like clusters like protect against agents that might misbehave in like pursuit of certain objectives that are set out for it. And the other aspect, like I said, is more on efficiency. They're like trying to benchmark and measure like how are the agents performing with respect to token cost, or like overall number of turns that it takes to reach an outcome, like fail to calls and things like that. And like sort of we aim to find differentiation of like different agent harnesses and models across like these multiple dimensions. So we are able to identify gaps where like either models or agents like sort of need to improve, and like what are the capability gaps that are present, and provide a feedback loop for any teams that are working on operational agents. Think we're close to time. I'm gonna stop here and like be happy to take any questions. And like Simran said, we have a roadmap published. Also, there's been a few folks interested in like collaborating, and I really wanted to signal boost to the community here, and wanted to invite more questions and contributions, or like help us in like solving some of these problems.
I see Aishwarya has questions. I'm sorry if I
No, you
messed
got
up
my
their
name.
name.
You got my
Go
name
ahead.
right. So I'm also part of the project. Just quick ask here is, we have a lot of PRs for review and a lot of tasks for open for contribution. So it's more of ask the community here. We'll also start engaging more in the SIG Apps channel. But if anybody's interested in contributing, please work with us. More than happy to take your expertise on shaping this further.
Awesome. Thank you. I'm not seeing any other questions. With that, we are literally at the top of the hour. Thank you very much all for today, and see you everyone in 2 weeks. Bye all.
Thank you.
Thank you.